Well, good morning, everybody. Welcome back to another episode of Math with Mr. Emond. Today we're going to be continuing on with rational expressions. This time, instead of multiplying and dividing them together, we're going to be adding and subtracting them together. Let's get started. So, one thing that I want you guys to realize is the processes are going to be very similar between how you would add and subtract rational numbers like this and how you would add and subtract rational expressions. So let's review. If I have things that have the same denominator, rational numbers with the same denominator, what do? I just combine the top. So 7 minus 3 equals 4. And my denominator stays the same, so it becomes 4/8. And I can simplify this to be 1/2. Now, if I don't have the same denominator, what do I have to do? Remember, you're allowed to change things as long as you multiply by 1. And why is that going to become useful? Well, what I'm going to try to do is come up with a common denominator. And usually, the easiest way to do this is to multiply by the same denominator as the other one. So I'll multiply by 1 to this one by multiplying by 5/5, and I'll multiply by 1 to this one by multiplying by 3/3. And you're going to see what happens here. When you multiply, the numerators multiply and the denominators multiply. What's 3 times 3? 9. What's 3 times 5? 15. And then I have minus 2 times 5, which is 10, and 3 times 5, which is 15. Now they have the same denominator. 9 minus 10 is -1 over 15. There we go. So this process, we all know how to do it. This is something we've been doing for a while now, but we're going to be applying this to rational expressions. Let's go. So just like the previous slide, there's going to be two cases that we need to take into consideration. The first case is when we have the same denominator. And all you're going to do here is you're going to add your expressions together. So you'll have x plus 5 plus 2x minus 6. All of it over 7. And we can simplify this, right? Let's just drop the parentheses. I usually put the parentheses there initially, especially if there's a negative sign, because you're going to have to distribute that negative sign. But since this is a positive, I can just drop it, and now I can add them together. So x plus 2x is 3x, and 5 minus 6 is minus 1. And this is over 7. It doesn't look like I'm going to be able to simplify any further. And so I'm going to be done with this one. I'll just box my answer. There we go. Now, in case 2, I'm dealing with a problem where my denominators are different. And this is where things start to get a little bit more complicated. But hopefully with the practice that we've been doing in previous lessons, you'll be able to identify the steps needed to be taken to solve these. So first step I'm going to do is I'm going to factor everything. So let's do the first one. 10 over, and I'm going to factor out this 3, and I'm left with x minus 4. Minus 3 over x minus 4. Now I'm going to take a look at these, and these denominators are very similar, aren't they? What's different? Well, this one's being multiplied by 3. And so how do I make them the same? Well, you guessed it. You're just going to multiply by 3/3, right? So now we have 10 over 3 times x minus 4 minus, what's 3 times 3? 9 over 3 times x minus 4. There we go. Now we have the same denominator. And what do? Combine them. 10 minus 9 is 1 over 3x minus 4. And we are done. That's as simplified as it will get. So hopefully you see, Just using our understandings of how to deal with rational numbers and applying them to rational expressions, you can quite easily solve these. You just need to be able to visualize what that common denominator will be if the denominators are different. Let's try another example. So the first one we have here is 2a over b minus a minus 1, and I like to put these in parentheses, over b. They have the same denominator, so I'm going to be able to just combine them. So I'll have 2a minus a minus 1, and hopefully you see now why when I have a negative sign I like to put parentheses, and it's because that negative sign is going to distribute. So I'll have 2a minus a plus 1, because this becomes negative a and negative negative 1. That negative sign gets distributed. And this is all over b. Now I can do my final step, combining them. 2a minus a is just a plus 1 over b. Final answer, lock it in, we're good to go. Let's do another one. These have the same denominator, I can just add them together. 2x plus 8 over x plus 4. I'm not going to be done just yet. And why am I not done just yet? I can see this can be factored. And as long as you can simplify, you're not done. You always want to keep going. So now I have 2x plus 8. I'm going to factor out a 2 from there. So what does that leave me with? X plus 4. 2 times x is 2x. 2 times 4 is 8. So this is equivalent expressions. This one's just simplified. And this is going to be over x plus 4. Now let's use our understanding from the previous lesson. If you have the same thing on top and on the bottom, they cancel out. That's why we don't stop. If we can continue to simplify, we do. And what is this equal to? 2 over 1, which is 2. Final answer. There we go. Okay, it's going to be your turn. Give these a shot. For those of you on YouTube, go ahead and pause the video now and come back when you finished working on them. See you soon. For those of you on YouTube, welcome back. We are going to go over the solutions for you. So this first one here, we started off by just combining the tops. So 2x plus 4 plus 7x minus 10 on the top, and all of it over x squared minus 9. Then we combine like terms. So 2x plus 7x is your 9x, and 4 minus 10 is negative 6. And now we did our final step. We looked at this and we looked for a common factor, and that common factor was 3. So we factored out a 3 and we were left with 3x minus 2. Then we looked at this and went, oh, that's a perfect square. So I can factor that into x plus 3 and x minus 3. Now, usually when you do this step, there are some things that you can cancel out, but as you can see here, there's nothing that we can cancel out, and that's as simplified as it gets, and that's our final answer. For the next one, we're going to again combine them. So you have 10a plus 5 minus 3a minus 2. And you have to be careful. Remember I said when there's a subtraction sign, you want to put this second term in parentheses, because this negative sign needs to be distributed. So you'll have 10a plus 5 minus 3a minus negative 2, so plus 2. That's going to lead to 10a minus 3a is 7a, and 5 plus 2 is 7. Now, what's your common factor here? A 7. So you can factor out a 7, you're left with a plus 1, and you have that all over ab, and that's as simplified as we get. That's our final answer. Let's try ones without common denominators. So what we're going to be doing now is trying to create problems that have common denominators. So let's do this first one. Now I'm going to look at these terms. So I have 2x over xy, I have 4 over x squared, and I have just a negative 3. And let's just put this over 1 because it's negative 3 over 1. Look at our denominators. Our denominators are xy, x squared, and 1. They need to become the same thing. So, how are we going to make that happen? Well, this one I'm probably going to have to multiply by an x because I need to get up to x squared. So x times x is going to give me x squared, and now it's going to be x squared y. So to match this one to that one now, this has to be multiplied by a y. So this is going to be x squared y, and this one's now going to be x squared y. What has to happen to this one? It has to be multiplied by x squared y. Okay, so now we've visualized what we're going to have to do. Let's start by actually doing it. So we're going to have 2x over xy, and we're going to have to multiply that by x over x, right? Because that's what we need to multiply by here. This is going to be plus 4 over x squared, and what am I going to have to multiply by? A y. So I'm going to multiply by y over y. And then it's going to be minus 3 over 1. And what am I going to have to multiply by here? X squared y. X squared y. Now notice the steps that I've taken. What I have done, actually first I'm going to put parentheses around everything, so we know that they're separate terms. Notice what I've done. This is just 1. X over x is 1. So I'm not changing this term. This is just 1. I'm not changing that term, and this is just 1. Essentially, all I'm doing right now is I'm multiplying by 1. I'm allowed to do that. I'm not changing my answers at all. I'm just getting them to a point where they have a common denominator. So now let's continue on with our multiplications. 2x times x is 2x squared, and this is going to be over xy times x, which is x squared y. This will be added to 4 times y, which is 4y over x squared y, and this is going to be multiplied by 3 times x squared y, which is going to be 3x squared y over x squared y. Now they have the same denominator, so now I can add them together. Let's get some more room to work with here, and let's combine them. So we have 2x squared plus 4y minus 3x squared y over x squared y. Let's look for common terms. There are no common terms. We're done. That's it. Put a box around it. Be confident in your math skills. That's as far as we can go. And I know you're looking at that going, this doesn't seem simpler than this, but it is, because now they're all one fraction. Okay? It would have been really nice if we could have simplified this, if it was factorable in some way. But this doesn't have an x, so we can't factor out an x. This doesn't have a y, so we can't factor out a y. And these are not all divisible by 2, so we're kind of done. Let's try this next one. Okay, let's look. So I'm going to do something a little different this time. I'm going to factor my denominator here. So this is y plus 2, y minus 2. And maybe you'll be able to see why I did that. Because now when I compare it to the other one, this one only has a y plus 2. So what am I going to have to multiply by to get them the same? Y minus 2. okay? When I do this, multiply by 1 in this way, I'm going to have the same denominator down here. And so sometimes whenever I look, right, if I see something that looks like it can be factored, I do that first. Notice I'm only doing it to my denominator because I want to see what the factors of my denominator are to compare them to the other ones to see what's missing. And I've identified that, so now I've just made my life just a little bit easier. Let's go y squared minus 20 over y plus 2, y minus 2, plus, and this is going to be y minus 2, y minus 2, over y plus 2, y minus 2. Now we can combine them. So we have y squared minus 20 plus, I'm actually going to factor this, okay? So I'm going to do that. I'm going to factor this. And this is going to be y squared minus 4y plus 4. And this is all going to be over y plus 2, y minus 2. Now I'm going to combine them. So we have y squared plus y squared, 2y squared. We have minus 4y. And we have negative 20 plus 4, which is negative 16. Over y plus 2, y minus 2. These are all divisible by 2, so let's factor out a 2. So now we have y squared minus 2y minus 8. And this, can we factor it? Yes, we can. So this is going to be y minus 4, y plus 2. Right? Y squared plus 2y minus 4y gives us that negative 2 minus 8 over y plus 2, y minus 2. And now you see the fruits of our labors. These are the same. We can eliminate them. And this leads us to our final step. We're going to have 2 y minus 4 over y minus 2. Final answer. There we go. So this was a lengthy problem, but none of the steps were incredibly difficult, right? We just kind of used our knowledge of math to work around things and get to a point where we can simplify. That's it. It's going to be your turn. For those of you on YouTube, now's when you pause the video and you work these out and you come back when you're done to check your work. See you soon. Okay, for those of you on YouTube, welcome back. Let's go over the solutions. So for this first one, what we did is we started off by multiplying by x over x on the right-hand equation, because we noticed that this was the only difference between the left and the right-hand side. By doing that, we created this, x minus 15 plus x squared minus 4x, and we combined the x minus 4x to be minus 3x. And now we looked at this and said, well, we can't factor it, so that is as simplified as you're going to get for that one. On this one up here, the first thing we did is we factored this. Now when we factored that, we got x minus 5, x plus 3. And then we noticed, well, this already has the x minus 5. So what is it missing? It's missing the x plus 3. And so we multiplied the 6x over x minus 5 times x plus 3 over x plus 3. This is going to create the 6x squared there and the 18x here minus 240. This, we realized, can be factored, right? These are all divisible by 6, and so we factored out a 6. And we were left with x squared plus 3x minus 40. At this point, we looked at x squared plus 3x minus 40, and we said, well, this can be factored, right, into x plus 8 and x minus 5. Now we have x minus 5 on the top and the bottom, so we can just cancel them out, and we're left with our final equation here. 6 x plus 8 over x plus 3. And that is it. We have one more example here. This is a mastery level question. Give it a shot, see if you can figure it out, and we will see you when you come back. Okay, for those of you on YouTube, welcome back. We have the solution for you. So the first thing that has to happen here is we have to realize that this is x over 1 and this is 1 over 1. And we can see that these two terms do not have the same denominator. This has a denominator of x, this has a denominator of 1. So what do we have to do to this one? Multiply it by x over x. This one here has a denominator of x and 1 as well, so same thing, multiply by x over x. Now x times 1 is x, and x times 1 is x. So you have x over x there. And here, x times x is x squared, and x times 1 is x. And so here, that's how you get to this step. Now, because they have the same denominators, we can combine them. So x plus 1 over x is going to be on the top, and x squared minus 1 over x is going to be on the bottom. At this point, you're going to have to do something to get rid of this. And I took that away because I want to make sure you guys know how to do this. We have to get rid of this whole denominator. And how do you do that? You multiply by the reciprocal. Okay? But we have to do the same thing on the top and the bottom. And so now you can see the reason for doing this is when you multiply these together, your x squared minus 1s will cancel out and your x's will cancel out. And the whole denominator just disappears. And when you multiply these together, we can see, again, there's a few common terms here. The x and the x will cancel out. So all you're going to be left with is x plus 1 over x squared minus 1. Now, this is the explanation of how to get from here to here, right? By multiplying by the reciprocal. But there's another little trick here. Because our numerator, like the numerator in terms of this larger fraction, because our numerator has a denominator of x, and our denominator also has a denominator of x, because they have similar denominators, what you can actually do is just cancel out those denominators. And the reason why you can do that is this, right? When you multiply by the reciprocal, they will just end up disappearing. And once you've done that, it just becomes your numerator over your numerator. And so you have x plus 1 over x squared minus 1. And if we look at these two terms, they're exactly identical, right? So being able to recognize that when you have the same denominator in an overall fraction, that you can just eliminate it and it becomes numerator over numerator is a very handy shortcut to know, right? And why this works? Well, you have to go back to this example that we did in order to understand that. Now we need to factor this. So x squared minus 1 is a perfect square, x plus 1, x minus 1. And we have like terms here that cancel out. And all you're left with, remember, this is being multiplied by an invisible 1. 1 over x minus 1. That's your final answer. Level 4 mastery question. That's it for today. See you next time. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end. And over here, you will find the next video in this unit. Keep learning, everybody. Take care.